For countless generations, humanity has gazed upward at the immense expanse of the night sky with wonder, pondering mysteries that stretch beyond imagination. Every twinkling star, every faint glow from distant galaxies, has acted like a silent riddle, urging us to ask, where did it all begin? How long has it existed? And what is our place in this unfathomable cosmos? In the 20th century, scientists introduced the Big Bang theory to explain the origin, growth, and expansion of the universe. According to this model, everything, space, time, matter, and energy, erupted into existence from an incomprehensibly dense singularity about 13.8 billion years ago. For decades, this explanation has provided a foundation for modern cosmology. Yet despite its wide acceptance, the Big Bang theory continues to face challenges, especially when confronted with evidence that appears to defy its assumptions. In recent years, scientific breakthroughs have only deepened the puzzles. In 2023, NASA's James Webb Space Telescope made a groundbreaking observation. It detected cosmic structures that seemed to have formed earlier than the universe itself. This was not just a minor inconsistency, it was a revelation that shook the foundations of astrophysics. The idea that certain stars or galaxies might predate the accepted age of the universe forces us to reconsider the very framework of cosmology. Could this contradiction be a sign that our model of the universe is incomplete, or even fundamentally flawed? Might we be on the brink of a scientific revolution where the boundaries of space and time must be rewritten? One of the most fascinating pieces of this cosmic puzzle lies about 200 light-years away, in the constellation of Lyra. There resides a star known as HD 140283, better known by its evocative nickname, the Methuselah star. At first glance, it appears like any other faint point of light, but this ancient stellar body hides secrets that may rewrite cosmic history. What makes Methuselah remarkable isn't just its staggering velocity, hurtling through space at 4,483 km per second, but its apparent age. Early studies suggested that Methuselah might be as old as 16 billion years, far older than the universe itself. Later refinements brought its estimated age down to about 14.46 billion years, still with a margin of error of nearly 800 million years. Even with that adjustment, the problem remains. How could a star be older than the universe in which it resides? This paradox challenges one of our most basic assumptions. The universe, based on current calculations of cosmic microwave background radiation, is around 13.8 billion years old. Methuselah appears to predate this timeline, defying the logic of creation itself. Could the measurements be flawed, or does this star hint that the universe is far older than our models suggest? The question has sparked debates among astrophysicists, driving them to revisit the methods used to determine stellar ages. Dating stars is no easy task. Unlike humans, stars don't carry clear birth certificates. Instead, astronomers must rely on indirect methods. One common technique involves measuring a star's color and brightness, comparing these observations with theoretical models of stellar evolution. Another method focuses on rotation. Like a wheel slowing down with friction, stars gradually lose their spin over billions of years. By studying their rotational speed, astronomers can make rough estimates of their age, a method known as gyrochronology. Yet even with these techniques, uncertainties remain enormous. Methuselah, whatever its exact age, is undoubtedly one of the oldest stars ever discovered. Whether it is older than the universe, or whether the universe itself is older than we believe, remains an open and tantalizing question. To grasp the enormity of these timescales, imagine compressing the entire history of the universe into a single calendar year. In this cosmic calendar, the Big Bang occurs at midnight on January 1st. Galaxies form by spring. The Earth itself doesn't appear until late December, and all of recorded human history fits into the final seconds before midnight on December 31st. Against this scale, a discrepancy of even a billion years becomes monumental, a sign that something in our understanding might be incomplete. The age of the universe itself is derived from measuring the light of distant galaxies and the expansion rate of space, what astronomers call redshift. As the universe expands, light from galaxies stretches into longer, redder wavelengths. By measuring these shifts and combining them with the Hubble constant, scientists arrived at the now standard estimate of 13.8 billion years. Yet a bold new theory from the University of Ottawa has thrown that figure into doubt. Physicist Rajendra Gupta has proposed that the universe might not be 13.8 billion years old, but closer to 26.7 billion years, almost twice as old as previously thought. His model combines modern cosmology with an older theory known as tired light, first suggested by Swiss astronomer Fritz Zwicky in 1929. According to this idea, light may lose energy as it travels immense distances, not solely because of expanding space. When combined with the concept of expansion, this could mean that redshift is influenced by multiple factors. If true, the universe may have been around for far longer than we ever imagined. This reinterpretation could solve the riddle of Methuselah and explain why some stars appear older than the universe itself. Our understanding of cosmic time has always evolved. In the 1920s, Edwin Hubble estimated the age of the universe at just 2 billion years, an estimate that was clearly far too low. Over the decades, refinements pushed that number higher, until we arrived at today's accepted 13.8 billion. But what if even that is still wrong? Could it be that the universe stretches back twice as far, and that what we think of as the beginning was not the true beginning at all? Adding to the mystery, new insights into our own Milky Way galaxy complicate the story further. Recent data from the European Space Agency's Gaia spacecraft, which has mapped nearly 2 billion stars, shows that stars on the outer rim of the Milky Way move far more slowly than expected. This has forced scientists to question long-held assumptions about the distribution of dark matter, the mysterious, invisible substance believed to make up most of the universe's mass. Some experts now suggest that our galaxy may contain far less dark matter than previously assumed, or that our understanding of dark matter itself is fundamentally flawed. If confirmed, this would have profound implications. For decades, dark matter has been the invisible glue holding galaxies together, explaining why they don't fly apart despite their rapid rotations. But if galaxies like the Milky Way contain less dark matter than we thought, then our entire picture of gravity, matter, and the architecture of the universe may need revision. The James Webb Space Telescope is now at the forefront of unraveling these mysteries. With its unparalleled ability to capture light from the most distant galaxies, Webb is showing us the universe as it appeared billions of years ago. Already, it has revealed galaxies that seem impossibly mature, existing when the universe should have been in its infancy. It is peering into the atmospheres of distant exoplanets, searching for worlds that might sustain life. It is also helping to refine our understanding of dark energy, the force believed to be accelerating the expansion of the universe. Each new discovery pushes us closer to a crossroads. Do the laws of physics we know hold true across all of space and time? Or are there hidden mechanisms at play, forces we cannot yet see or understand? Every observation, whether it is of an ancient star, a distant galaxy, or the faint background radiation of the cosmos, adds pieces to the puzzle. Yet with every answer comes more questions, pulling us deeper into the mysteries of existence. Perhaps the universe is older than we think. Perhaps there were epochs of creation before the Big Bang, cosmic cycles of birth and destruction beyond our current imagination. Or perhaps our tools and theories are not yet advanced enough to grasp the full picture. Whatever the truth, one thing is certain: humanity stands at the edge of a new era of discovery. The next decades could transform our understanding of time, space, and life itself. Even the possibility of discovering microbial life on another planet would be revolutionary, altering biology, philosophy, and our place in the cosmos forever. And as we learn more about dark matter, dark energy, and the hidden architecture of galaxies, we may find ourselves forced to rewrite the very rules of reality. For now, the universe continues to guard its secrets. But our pursuit of knowledge, driven by curiosity, wonder, and an unshakable desire to understand, ensures that we will keep searching. The cosmos has only just begun to reveal its story, and each revelation brings us one step closer to the ultimate truth of existence. Stay tuned for more explorations of these mysteries. If you want to follow along with the latest discoveries in astronomy and astrophysics, don't forget to subscribe, like, and turn on notifications. The universe is vast, mysterious, and full of secrets waiting to be uncovered. The greatest discoveries may still lie ahead, beyond the edge of the known cosmos.